Okay, right. So here there are like some questions, like 7 questions for integration. Mainly this is related to C4 and some syllabus is C3. Like Edexcel and similar ones actually C4. Anyway, this is integration. So let's try to integrate these functions, these expressions. The first one actually is written here, the 1 over 1 plus 2x squared dx. So we try to integrate this now. At a glance, we can see that 1 plus 2x is a linear function, isn't it? So when this is linear, linear means basically in this format, linear should be a plus bx type. A and b are constants. We are writing it. A plus bx type. A and b are constant. So you can clearly see that's a plus bx type of function, linear function. When it's linear, we can do this one easily. We can bring this from the top. We can have 1 plus 2x to the minus 2 dx. Now we can integrate like a standard integral. We can add 1 to the minus 2. We're going to get 1 plus 2x minus 2 plus 1. I'm just writing for the time being the operation, minus 2 plus 1. And the answer is here, minus 2 plus 1. I'm just writing just for clarification. So we can now simplify it. So what you're going to get here basically 1 plus 2x to the minus 1 over minus 1. However, this is not the end. Now we should differentiate the internal function. If we differentiate 1 plus 2x, what you're going to get is 2, isn't it? Because in differential of 1 is 0, differential of 2x is 2. So I'm going to divide the whole thing by that differential. Divide the whole thing by the differential. So the final answer would be, when you're dividing like this, we know these two things will be times. Okay? So they will be times basically when you're dividing like that. Yeah, it's like saying half divided by half. If you divide half by half, if you divide half by 2, what you're going to get? You're going to get quarter, isn't it? So the same idea. See, half divided by 2 would be quarter, because why? 2 times 2 is quarter. Justification. Okay, so so that's the idea. So here what we're going to get is 1 plus 2x to the minus 1. There will be times, you're going to get minus 2 plus c. That's good enough. That's good. That's the different integral of that. These are open integrals, so just that's the answer. Don't forget c when it's open integral, otherwise you'll lose marks. And also it's very important in general in integration, adding arbitrary constant to c. That's basically it. Or if you want, you can rewrite this one, much more purified version of it. You can write this one, minus can be brought to the front or the top. You can write 1 plus 2x to the minus 1 over 2. That's also fine. Okay? Equal answers. Or even somebody might say that can be, the power can be brought down. You can write another version of the answer like this. They're all the same. We can write it like this as well. 1 plus 2x. Because why? I can bring this one down, so it's become like that. 2 remain there, plus c. Okay, so they all are equal answers. This is much more, this is somewhat purified version of it than that. The sort of raw answer. All the same. So it depends on what you really want, in what context, in what format. Okay, so cool. So that's something about it. So keep in your mind, when that is linear, you can do all these things. If it's not linear, then you can't really do that. Let's say the question was 1 plus 2x squared here, inside. Then you can't really perform this method. It will be wrong, basically. Then you require some different method. Okay, so that's basically it. All 3 answers are equally valid. Okay, so let's go to the next question. All right, question number 2. It's a trigonometric expression. They say integrate 5 times sine 7x plus cos 3x dx. When you see something like that, sine and cos being times, sine and cos being times, or cos and cos being times, or any of these what do you call combinations, sine times sine, sine times cos, cos times cos, that sort of stuff, one thing should come into your mind. What is that? Factor formula. Factor formula. Basically, we can break it down to sine A and sine B. Sine A plus sine B. We can break it down. You know, we can rewrite this one because we can remember from C3 trigonometry. When I'm saying C3, I'm referring to Excel basically. In generally speaking, sine A plus sine B would yield this. 2 sine A plus B divided by 2 cos A minus B divided by 2. Now you can clearly see that this is in this format. So if we can find A and B, then we can bring it back. We can rewrite it in that format. Right? However, instead of 2, we had 5 there. So it's a very simple, it's not a big deal actually. Having 5 should not be a problem, because what we can do, we can rewrite this question like this. We can make this one 2. We can write 2 here. 2 sine 7x cos 3x dx. And we can take the 5 out and put 2 there. See, it's the same thing. Because they cancel out, you're going to get again 5. So if you can integrate this one, if you can rewrite this one, that bit, basically, in the format of that, then we can integrate each one like that. So to do that, what we're going to do, we're going to rewrite this one. We say we know we can rewrite this one like this, pi over 2. That can be written as sine A plus B divided by 2 cos A minus B divided by 2. Okay? Right, according to this, the factor formula. This is called factor formula. Basically, this is how we factorize sine A and sine B. Sine A plus sine B can be factorized this way. Quite a powerful technique in trigonometry. We can exploit that here. Okay. So what we're going to do now, we can find A and B values. To do that, we can see A plus B divided by 2 should be equal to 7x, isn't it? So we can say 7x equals A plus B over 2. Similar fashion, 3x equals to A minus B over 2. That's yield us here 14x, that's equation 1, that's equation 2. Okay. Multiply by 2, the first equation, we're going to get 14x equals A plus B. Second one can multiply by 2 again, just the same thing. We're going to get 6x equals A minus B. Add them together, you're going to get 2a equals 20x. 20x equals 2a. And a equals 10x. A equals 10x, so we can find b easily. B would be minus, you can sub a into that, you're going to get b equals to minus 6x. Sorry, minus a equals to 10x, so b equals to 4x basically. And b equals to 4x. This bit of simple simultaneous equations. Okay. So there you go. So we got a and b. Now we can sub it back into that. All right. So I think so I can write down pi over 2. That can be replaced by sine A and sine B. Sine A is 10x plus sine B is 4x dx. Okay, so integrate each one now. We integrate sine 10x, what are you going to get? Minus cos 10x, isn't it? Divided by 10. Integrate that, we're going to get minus cos 10x over 10, right? Okay. If you integrate sine normally, if you integrate sine x, you're going to get minus cos x. If you integrate sine 10x, you're going to get minus cos 10x divided by 10. The differential of 10x is 10 basically. In a similar fashion here, differentiate sine 4x, we're going to get minus cos 4x divided by 4. Okay, plus c. Alright, so now I can expand the brackets. What I'm going to get here, minus 5 cos 10x divided by 20 minus 5 cos 4x divided by 8 plus c. That's it. That's basically the answer. Okay, that's it. I think it's quite simple once you realize the factor formula. So the tip is this: whenever you see something multiplied, sine times sine, cos times cos, sine times cos, they all the times we can use this equation. However, they cannot have like sine squared terms, then it's difficult. We can employ a similar technique in those cases as well. Probably in the future clips I'll talk about it. We can utilize it in a slightly different manner. But for the time being, that's quite straightforward. Okay, I think that's clear enough. Right, so let me get rid of this, tick off the next question. Yeah. It's question number 3. Ex plus cot squared x, cot squared 4x minus 1 dx. Okay. There are two different type of functions here added together, so we can integrate them separately. Okay. So ex integral of ex is basically ex, isn't it? So integral of ex is ex because differential of ex is ex. So it's pretty simple. That is. So we got ex. We have integrated that already. Plus we can integrate that. Now cot squared. Cot squared x, that's a linear function. So if we can integrate cot squared x, then we know we can integrate that easily because it's a linear function. Cot squared x, is it given? Cot squared x. I think standard booklet, the cot squared x is not given. But what is given is cos x squared x. You guys should be familiar with the integrals that are given, standard integrals. Otherwise, you might be just wasting time just trying to integrate this one in different methods or something. There are a certain number of standard integrals are given on the booklet. I think what is given, sin and cos I think is not given. I mean, they would expect you to know it. What is given is basically sec x is given, tan x is given, cot x is given, cosec x is given. See? All the other things are given except sin and cos, I think. And also, there are some special things are given. Sec squared x is given. Cosec squared x is given. Cosec squared x is given. There are another 2 is given, if my memory is right. Sec x tan x is given. Cot x, cosec x is given. See? And there, we had cosec squared x is given. Cosec squared, but cot squared x is not given. But however, we can convert this one into cos x squared x. Yeah, because we know 1 plus cot squared x equals to cos x squared x. That's the, I think, a relationship we learned in C2 or C3. Can't remember. However, you should know this one. I think C3, obviously. C3, in Excel again I'm talking about, but maybe other syllabuses slightly vary. So we can use this ID and we can replace cot squared x with cos x squared x. So I can rewrite this one as cosec squared 4x minus 1 minus 1 dx. Okay, because x can be replaced as 4x minus 1 and 1 remains 1. Alright, so basically we've been using this idea. Okay. Now we can integrate that. So the answer would be, I'm just going to get rid of this to get some space. Ex is already integrated, Ex, no changes there. Cos x squared x integral is minus cot x. Then if it's cos x squared 4x minus 1 would be then minus cot 4x minus 1, because that's linear again, very similar to the first question, a linear function is linear again, that however divided by the differential of 4x minus 1. What's the differential of 4x minus 1? 4. So divided by 4 and plus c. That's it. So I think pretty straightforward question, right? Oh, sorry, we missed one thing here. We had minus 1 as well, so minus x plus c. Okay. So then let's move forward to the next one. Number 4. 1 minus x squared dx. They say use a substitution, x equals sine theta to do this. X equals sine theta. For an example, we can't, forget about substitution for a minute. We can't integrate this one just directly for an example. Somebody might be thinking, okay, I'm going to integrate this one like this. Some students, they do this actually. They think they can integrate it like this. That's half, isn't it? Power is half. They would add 1 to this. They're going to get 3 over 2. They divide by 3 over 2. And also what they do, they would differentiate this x squared and put 2x here. Which is totally wrong, unfortunately. The reason is this, like I previously mentioned, this should be a linear function to do that. This is not a linear function, this is a quadratic function. Non-linear function basically, so you can't do that. So in this kind of cases, so probably we can use a substitution. X equals sine theta, so I'm going to replace x with sine theta. 1 minus sine squared theta dx. And again, I can see that I can't integrate in terms of dx when I have theta, so I had to replace dx with a function of theta. So the best thing we can do, we can differentiate this. We're going to get dx or d theta is equal to differential of sine theta would be cos theta. And I can write that dx can equals to cos theta d theta. So I can replace dx with that. And 1 minus sine squared theta d theta, dx can be written cos theta d theta. That's become 1 minus sine squared theta is cos squared theta. Cos squared theta square root will be cos theta. So cos theta times cos theta d theta, which is cos squared theta d theta. Okay. So cos squared theta, again, it's not a standard integral. It's not given in the booklet. So, however, we know the integral of sine theta, cos theta, that kind of stuff. So we can use double angular formula to rewrite this one in the format of possibly cos theta, isn't it? Because we know cos 2 theta equals 2 cos squared theta minus 1. Alright? So I can replace cos squared theta with cos 2 theta plus 1 divided by 2. Alright, that's cos squared theta. Can replace this with this. What I'm going to get then, cos 2 theta plus 1 divided by 2 means I can separate the 2's. Okay. So now I can integrate each one easily. Cos 2 theta divided by 2 can be integrated to give sin 2 theta. Sin 2 theta, don't forget, again you have divided some by 2 because 2 theta, like a chain rule, 2 theta can be differentiated to give 2. So 2 divided by 2 would be again here, become 4. I mean, because you have 2 here, because 2 with 2, so 2 times 2 basically 4. And this become half theta plus c. Okay. However, the game is not over yet. The reason is our initial expression was in x. Now we got integral in terms of theta. So we should be able to replace this theta with x. Because we know x equals sine theta, isn't it? So that we can write theta equals to sine inverse x. Okay. So in here, obviously x should be in between plus or minus 1. It just validates there as well. So now we can sub theta into this. I can replace easily theta with sine inverse x, that's fine. But sine 2 theta, how can I replace that? So that seems to be a bit, we have to do a bit more work here. Okay, so let me get rid of these little things we did here. Okay, to get some space. Because that bit, let me use another color, possibly. So I'm going to write this one like this. 2 sine theta, basically I'm going to move from there to there. Sine 2 theta can be written as 2 sine theta cos theta. 2 sine theta cos theta. 4 is there. And half the theta plus c. Right, cool. Now I think we got it. Sin theta can be replaced with basically straight away x. We got it, 2x. Cos theta means 1 minus sine squared theta, isn't it? Square root of it. So 1 minus sine squared theta, can write 1 minus sine squared theta. The reason I'm writing in sine, because I know that I can replace sine with x, basically. And that's divided by 4, plus theta is half. Theta is basically equal to sine inverse x plus c. Now I can replace this sine squared theta with x squared. Okay, so what I'm going to get 2x, 1 minus x squared divided by 4, which can be simplified a bit actually already here. 2 plus a half sine inverse x plus c. That's the complete answer. Whew. There you go. So that's basically it. It looks like a very simple question, but it goes quite some length, isn't it? Yeah. So basically it's all about substitution. Substitution, they're not really bad once you understand. You have to be patient as well. Okay. That's question 4. That's the final answer. I hope I haven't done any numerical errors. If there are, please you can comment on these little errors. Sometimes we can do little errors, little mistakes. Alright, so, but however this is the method to go about it. Cool. So let's go to the next question then. Question number 5. Okay, question number 5 says, question number, there are 2 4s here. Sorry. So this is basically, there are 2 4s, but somehow That's for this 5. This is question number 5. Yeah. That's become question number 6. It's become question number 7 then. It's become 8. So there are 8 questions. Yeah. So question number 5 says 3 sine theta divided by 1 plus cos theta d theta. Right. What we can do for this? Now we can see the differential of 1 plus cos theta is on the top. I mean, we can make a similar one. For example, if we differentiate 1 plus cos theta, you're going to get minus sine theta. We got sine theta. So we can turn this one into minus sine theta like this. Minus sine theta, take the minus out, and 1 plus cos theta. See? I think we have not violated the initial function. Minus minus can become positive. 3 is there. So that's the same thing. The whole idea is to get the differential of this. If you can find on the top, then we know the integral will be ln, isn't it? Ln the denominator. Okay. The ln the denominator. So the differential of 1 plus cos theta is minus sine theta is on the top. The answer would be then minus 3. When integrate this, become ln 1 plus cos theta. Okay. Plus c. That's it. Pretty simple. Can be written like this. Yeah. All right. So the modular sign is quite important because ln can't be negative. Okay. So I mean, ln means this ln x value cannot be negative. So if you look into ln function, the ln function look like this. Ln x. That's x. See, x only and positive. So that's like the x should be positive bigger than 0. So if you want actually by that, we can even get a range for theta as well. If we want 1 plus cos theta is bigger than 0 kind of thing. Anyway, 1 plus cos theta would be always bigger than 0 in a sense, isn't it? Because you can raise everything by 1. If you look into 1 plus cos theta function, everything just goes up by 1, isn't it? But anyway, that's not relevant here. Just discussing. This should be positive basically. And also, if you want, we can write the same thing in a slightly different format. This is a log, isn't it? So we can bring this minus 3 there. You can write as a power. Even though this is not necessary, in some context they can ask you to write in this format. Minus 3 plus c. That's minus 3 power. Again, I can bring it down like this. Ln 1 over 1 plus cos theta cube. Plus c can be, if I want, I can replace it with ln a. Because it's a constant anyway. I can just put ln c or ln a or whatever. Ln c or ln a basically. Not ln c, ln a. So I can rewrite this one as much more compact version of it. When I'm adding logs, I can times these values together. I'm going to get a over 1 plus cos theta cubed. That's it. It's not necessary, but you can write like that. It's sometimes they can ask you to write it like that. Okay, that's basically a. But this is good enough. You can, at least you can do that bit. Right, so that's basically it. All right, so let's move forward then to the next question. Question number 6. Question number 6 is basically says 3 sec squared x tan to the power of 4 x dx. Okay. This look weird. So because it is very high powers as well, power of 4, I know that. So how we can do this? Just 3 is just a number, isn't it? So I can just take it out. Just take it 3 times. So I can rewrite this one like this. Probably it might be less clutter. Sec squared x tan 4x dx. Okay. A way would be this. There's a method here called inspection method, observation method. So what we can do here, we can see this slide is similar to the previous question in a different way actually. So it's pretty similar in a sense. Sec squared x, I can write tan x to the power of 4. The same thing I have rewritten like this. Okay. Now, the same thing basically. Can you see tan x? The differential of tan x is sec squared x. The differential of tan x, see, not the whole thing, the only that bit. The differential of this, basically sec squared x. So if we get these sort of functions in this fashion, we can know the answer straight away in a very simple fashion. We can write the answer for this one. Integral would be tan x raise this power by 1, 5 divided by 5 plus c. Basically, let's put c bit later on because we have 3 here as well. So we can write 3 tan x so forth plus c. That's fine, basically. That's the answer. We can show this one, this right. If I differentiate this one, I'm going to get straight away that. Differentiate it, 5 comes here, 5 cancels out. So you got 3 tan x. Then I'm going to differentiate tan x, I'm going to get sec squared x. See? So if I differentiate this, I'm going to get the same answer there. So that's the answer, simple. Okay. This is based on the idea of this. Let's say that's fx to the power of n. N is unequal to 1 basically, unequal to minus 1. Unequal to minus 1. And cannot be